Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Its architecture consists of several key components working together to provide a robust and scalable platform. Here's an explanation of each component in a Kubernetes cluster architecture. 1. Master node. The master node is responsible for managing the cluster and its various components. Components running on the master node include API Server, exposes the Kubernetes API and acts as the frontend for the Kubernetes control plane. Scheduler, assigns pods to nodes based on resource availability and other constraints. Controller Manager, monitors the state of the cluster and ensures that the desired state matches the actual state. ECT, a distributed key value store that stores the cluster's configuration data and the state of the cluster. 2. Worker node. A worker node, also called a minion, is where containerized applications run. Components running on the worker node include Kubelet, an agent that runs on each node and communicates with the Kubernetes API Server. It manages containers on the node and ensures they are running as expected. Kube-proxy, maintains network rules on the node and performs connection forwarding for Kubernetes services. Container Runtime, the software responsible for running containers, such as Docker or Containered. 3. Kubelet. The kubelet is an agent that runs on each worker node and communicates with the Kubernetes API Server. It is responsible for managing containers on the node, including starting, stopping, and monitoring containers. 4. Kube-proxy. Kube-proxy is a network proxy that runs on each worker node and maintains network rules on the node. It performs connection forwarding for Kubernetes services and ensures that network traffic is properly routed to the appropriate pods. 5. ECT. ECT is a distributed key value store that stores the cluster's configuration data and the state of the cluster. It is used by Kubernetes to store information about the cluster, such as node and pod metadata, service endpoints, and configuration settings. 6. Kubernetes API Server. The Kubernetes API Server exposes the Kubernetes API, which allows users and components to interact with the Kubernetes cluster. It serves as the frontend for the Kubernetes control plane and is responsible for processing API requests, validating them, and updating the ECT data store. 7. Controller Manager. The Controller Manager is responsible for monitoring the state of the cluster and ensuring that the desired state matches the actual state. It includes several controllers, such as the Replication Controller, Endpoint Controller, and Service Account Controller, which are responsible for managing different aspects of the cluster. 8. Scheduler. The scheduler is responsible for assigning pods to nodes based on resource availability and other constraints. It evaluates various factors, such as CPU and memory resources, pod affinity and anti-affinity, and node taints and tolerations, to determine the best node for a pod to run on. 9. Container Runtime. The Container Runtime is the software responsible for running containers on the worker nodes. Kubernetes supports various container runtimes, including Docker, Containered, and CRIO. These components work together to provide a scalable, resilient, and self-healing platform for deploying and managing containerized applications in a Kubernetes cluster.